In this lecture, we will look at examples. The first one says that is sine 2 theta equals sine theta times cosine theta an identity? If it is not, show it. Okay. Look, we know sine 2 theta equals 2 times sine theta cosine theta is an identity. Okay, that's the double angle formula. Okay, if you don't remember, you may see how we actually proved this one. Okay, so there is a 2 in front of sine theta times cosine theta. And then which values you plug into here, you plug in here is going to be an identity. But this one without 2, then it will not be an identity. Okay? So then you may say sine 2 theta equals sine theta and cosine theta is not an identity. Well, here it asked that if it is not, then you have to show it. To show an equation is not an identity, you want to do is find a value, you plug into here, and it will make the left-hand side not be equal to the right-hand side. Then you are done. Okay? Here is ask you to show if this is not an identity. Okay. Okay. Now, you may choose value theta equals pi over 4. There are other values you can choose. Okay. Here we may choose is pi over 4. Some of you may choose pi over 6 to check it. Okay. And then you may find out it's not identity also. Okay, so here let's choose pi over 4. If theta equals pi over 4, then sine 2 theta is sine 2 times pi over 4. Okay, and then pi over 4 times 2 is pi over 2. And then sine pi over 2 is 1. That's left-hand side is 1. Okay. Now, right-hand side, if you plug in pi over 4 into those two places, sine theta times cosine theta is pi over 4, and then times cosine pi over 4. Okay. Yeah. Now, recall sine pi over 4 is radical 2 over 2. Cosine pi over 4 is radical 2 over 2. Now, radical 2 times radical 2 is 2, and 2 times 2 is 4. So, which is 1/2 for this one. Okay, yeah, so 1/2 does not equal 1. Then you will see sine 2 pi over 4, this one, is not equal to sine pi over 4 times cosine pi over 4. So then you may conclude sine 2 theta equals sine theta times cosine theta is not an identity. Okay, so that's why, you know, basically if we have a 2 in front of it, 2 times 1/2, you will get 1. So the above is an identity. And down here is not an identity. So we are done because we have a find a value pi over 4, and then this equation is not satisfied. So then we say this equation is not identity. Okay. All right. Now, to prove, by the way, you are done here. But if you want to prove this one is identity, basically it takes a lot of work. You have to do it by using formulas, okay, sequentially to prove that. But here is that we want to prove this one is not identity, okay? All right, now let's look at the second example. The second example says that is an application question. If we let the energy stored in an indicator be given by L of t equals 3 times cosine 1 million t squared, and we also let the energy stored in a capacitor given by C of t, which is 3 times sine 1 million t squared. Okay, so the total energy E of t will be the sum of L of t plus C of t. And here is the question. Graph the three functions and simplify expression E of t, which equals L of t plus C of t. Okay, the simplification might be easy. You see E of t is the sum, so then L of t you may write from here, which is 3 cosine 1 million t squared plus 3 sine 1 million t squared. C of t is 3 sine 1 million t squared. If you pull 3 out, because there are 3 here, 3 here, you pull it out, then inside it will be cosine 1 million t squared. The second one is sine 1 million t squared. This is an identity equals what? By Pythagorean theorem, those two angles are the same, then you will have add those two together, 1 squared plus another squared is 1. Okay, so then 3 times 1 is 3. Alright, so actually the simplification is easy. E of t is actually equal to 3 units. Now the thing is that the graphing for E of t is also easy, because E of t is 3, so it's a horizontal line. Okay, that's the easy part. The thing is that we want to graph L of t and C of t. This 1 million t is a very big number. Okay, so down here, if you input the function L of t right here is 3 times cosine 1 million x parentheses squared. And if you don't set up the window size clearly, you set up like that. -10 to +10, -10 to +10. That was a standard window size. When you graph it, it's a messy. It's like that. Okay, it's like that. And then you have no idea how does it look like. Okay, but this is the coefficient 1 million t. Then if using this one as a denominator to divide 2 pi, then probably you will get a t. Some of you may think absolutely that's the t, but actually it's not. It's not. The actual period t is smaller than that. Okay, you can see how many are actually inside. Now, here, you may set up your window. Here 3 cosine 1 million t squared. So then you may set up the y, smallest one is -1. You may set up from 0 because this one is greater than or equal to 0. Okay, but I like to set up a little bit lower. All right, and here the 3, you may set up a little bit greater than 3. So for y maximum, you may set up 4. Okay, so that's the vertical one. Horizontally, you may set up here is 0, starting from 0. And then you do is 2 pi divided by 1 million. Okay, I said previously that the period may be this one, but actually it's not, smaller than that. Okay, so for x is from 0 to 2 pi divided by 1 million. For y is -1 to 4. Okay, after you set up this one, you then can graph it. Okay, this is from 0 to what? To 2 pi divided by 1 million. So you can see from 0 to the halfway is a 1 period, and from this place to here is another period. So from 0 to 2 pi over 1 million, it has 2 periods. All right. So basically the period is pi over 1 million. All right. Yeah, it's not 2 pi. So from 0 to 2 pi divided by 1 million, it has 2 periods inside. Okay. All right. Then how about what? How about this one? Okay. On my graph right here is this branch. So I wrote L of t. Okay, and E of t is this horizontal line. C of t is actually like this. You can graph it. You see down here, you may input 3 parentheses sine 1 million x. Okay, and then parentheses. This one goes with this one. So you need one more, and then squared. Okay, you then can graph it. This is the, is that a mistake right here? Look, I probably, you see, I probably need to do is that was the first equation. What I want to do is what? Second one, okay? Cosine and then sine 3. No, here's not 3 anymore. 1 million. And then x parentheses squared. This should be right. Previously I put this equation into the first one. Okay, so into a graph, the cosine, this one again, and then second one shows up. Okay, yeah, that will be the graph. All right, so please review this lecture. I'll see you next time.